A brief study on biohydrogen production from pharmaceutical wastewater using environmental anaerobic technology. This important article is authored by the following scientists. Hydrogen as a sustainable energy carrier has garnered considerable attention due to its clean, high energy yield and renewable nature. Recently, hydrogen production through a biological approach has attracted significant interest and is deemed to be one of the emerging areas in bioenergy research. Hydrogen, H2, is considered as the future fuel. The present work is an appreciated approach to wealth generation through value addition to waste. The optimization process included the selection of an ideal co-substrate, sucrose, and nitrogen source, DAP, to examine the feasibility of hydrogen production from industrial effluent in a 50% to 50% mixture of the complex feed and the industrial effluent. Hydrogen gas produced in the reactor is estimated using a gas sensor. This equipment is a generic gas monitoring instrument with microprocessor-based electronics interfacing with STD. 4 to 20 Ma alarm control systems. The inlet pH, feed, was maintained at 6 while the outlet pH monitored after detention time showed a slight variation, 4 to 5.4, throughout the reaction periods. The variation in volatile fatty acids, VFA, was evident up to 21 days of operation and thereafter stabilized in and around 2600 mg per liter, indicating the steady-state condition of the reactor. The alkalinity values variation indicated an increase in system response to the acidogenic fermentation process. The anaerobic stirred tank reactor showed consistency in its results on feeding with the synthetic feed. This set of experiments aims to study the variation of process parameters by using the optimized co-substrate and nitrogen source as the feed for the reactor. The variation of chord reduction, % indicates a multitude of variations as the experiment proceeds, indicating perfect degradation of the organic substrate present in the culture aimed towards hydrogen production. VFA evaluation through high-power liquid chromatography, HPLC, indicated the presence of acetic acid within the system, which could be the possible substrate for hydrogen production. During sequencing phase operation, the hydrogen values given by the experimental run with the effluent as the main substrate showed a greater production rate, 0.81 mol HR, when compared to that produced in the previous cases using only synthetic, 0.086 mol HR, and complex feeds, 0.29 mol HR, respectively. The described process has the dual benefit of combining H2 production and wastewater treatment in an economical, effective, and sustainable way. In conclusion, the study demonstrated the feasibility of H2 generation from pharmaceutical wastewater treatment by anaerobic fermentation in a suspended growth bioreactor using anaerobic mixed inoculum. Introduction. Hydrogen is a clean and efficient fuel that produces only water when used, making it a great alternative to fossil fuels, which contribute to pollution and climate change. Most hydrogen today is produced from fossil fuels, which is expensive and harmful to the environment. To address this, scientists are exploring eco-friendly ways to produce hydrogen using biological processes, also known as biohydrogen production. One promising method is dark fermentation, where certain bacteria break down organic waste materials to release hydrogen. This method not only produces clean fuel but also helps in treating harmful waste. In particular, pharmaceutical wastewater, waste from drug manufacturing, can be used as a source for this process. Such wastewater contains harmful compounds, including antibiotics, which pose a risk to the environment and public health if not treated properly. By using pharmaceutical waste in biohydrogen production, we can tackle two problems at once: generating clean energy and treating toxic waste. Scientists are experimenting with different systems and setups, like reactors with mixed bacteria and specific nutrients, to improve hydrogen yield. One challenge is to suppress certain bacteria that produce methane instead of hydrogen. Researchers address this by adjusting operating conditions and using specific reactor designs that favor hydrogen-producing microbes. New technologies, such as microbial electrolysis cells, MECs, are also being studied to boost hydrogen output further, though they come with their own challenges, such as controlling unwanted methane formation. This study focuses on producing hydrogen from a mix of nutrient-rich feed and pharmaceutical wastewater. The goal is to develop a sustainable, affordable, and easy-to-use system that produces hydrogen efficiently while cleaning up harmful industrial waste. Conclusion. This study explored the possibility of producing clean hydrogen fuel from pharmaceutical wastewater using a special type of bacteria in a simple reactor system. The process works by breaking down the waste without oxygen, using a mixed group of microbes. Results showed that how much waste is added, organic loading rate, affects how much hydrogen is produced. The conditions in the reactor, like maintaining an acidic pH of 6, helped increase hydrogen output. The system used, a suspended growth bioreactor running in cycles, proved to be easy to operate, flexible, and low cost. It also allows the bacteria to grow in a way that boosts hydrogen production. This approach offers two big advantages: it treats harmful pharmaceutical waste and produces clean energy at the same time. Ongoing research is focused on improving reactor design, understanding the microbes involved, and finding ways to increase efficiency, making this a promising solution for sustainable energy and waste management. Thank you for watching this video. Please subscribe to our channel BP International to watch more videos in the fields of science, technology and medicine.